quick little tour of MicroQuiz Module 1.5. Students attending a student activity showing Hobbs and Shaw were asked, how many movies on Netflix or YouTube have you streamed this month? One sample consisted of just freshmen. They responded 5, 1, 2, 5, 3, 4, and 8 movies. What is the sample size N? So for number 1, our sample size is, 1, 2, 3, 4, 5, 6, 7. 7 students, 7 freshmen. Present this data with an appropriate plot or graph using the labels. So these are counts. That means they're quantitative. So, and X equals the number of movies. It's collected, it's quantitative. It's counting, so it's discrete. Quantitative variables, we can use dot plots. We could use stem plots. Let's see, you could do a histogram. Probably missing one. Box plot. All these are plots to represent the distribution of the number of movies. Since I have 5, 1, 2, 5, 3, 4, 8, I don't think a stem and leaf plot are going to be appropriate. I could do a dot plot really quickly. So number of movies. So 1, 2, 3, 4, 5, 6, 7, 8. And just going through the data and putting a dot over each one of the values, I've recorded 5, 1, 2, 5, 3, 4, and 8. So that would be a dot plot. Now that I have them in order, I can also see that halfway through this list of 7, so that means the fourth value would be the median. So 3 would be the lower half, these 3 would be the upper half, and the median would be 4 movies. Cutting this lower half into half, the first quartile would be 2 movies. So 25% of the observations are below 2, 75% are above. The third quartile would be the upper half, cut in half, so that would be 5 movies as well. And so one observation, or 25%, occur above 5, and we have 75% are below. So 5 movies, just tying in our concept, would also correspond to the 75th percentile. 2 movies would correspond to the 25th percentile. Alright, so I could do a box plot. I have my 5-number summary. My minimum is 1 movie. My maximum is 8 movies. And so using a box plot, 1, 2, 3, 4, 5, 6, 7, 8. My box plot would have longer segments at the quartiles, so at 2 and 5. So at 2, I'll just move down, and at 5. And what is that's the first and the third quartile. So the IQR, my interquartile range, is 5 movies minus 2 movies, which is 3 movies. That's that middle 50%. Occur between 2 and 5. And the median was 4. So that completes my box. The whiskers are going to go out to the largest value and the minimum value. And let's see, present this with an appropriate graph using labels. So the box plot of movies, a sample size of 7 freshmen. And you could label this the dot plot of movies for 7 freshmen. That would have also been acceptable. A stem and leaf plot, not very exciting. Just to review, so no 10s digits, only 1s digits. You would have a leaf at 1, 2, 3, and 4. The leaves for the other values would be 5, 5, and 8. So this would be a stem plot for the number of movies. So I've represented it in 1, 2, and 3 different ways. Let's see, give socks. So, shape. So the shape looks like a long tail here, but I've also got some kind of distribution over here. This is a possible outlier 8. Does that look like, no, this looks like it's more stuck together from 1 to 5, and then 8's a long tail. So the box plot indicates more of a right skewness. And with the stem plot, I can't really tell any kind of skewness. It looks more symmetric. I'm going to hold off for a minute and look at just what is the mean, and look at the median and see if I know what the median is. We found that to be 4 movies. Let me just put this in a calculator and see if there's any value. So I had 1, 2, 3, 4, 5, 5, and 8. If I calculate the 1 var stats using, this was in list 1, there is no frequency. Calculate, so paste that to the main screen. The mean is 4 movies. All right, so the mean is 4 movies, which happens to be the same as my median. So I'm going to say that this skewness here is kind of canceled out because the spread between the second quartile to the median and then the spread over here from the third quartile to the max kind of balanced out our distribution, making the shape, since the mean and the median are exactly the same, I'm going to call this symmetric. So I had to use my statistics to figure that out. That's my shape. Let's see, outliers. Since I'm using a symmetric shape, I'm going to use the mean. X bar is a symbol for a sample mean, and we just found that to be 4 movies. Let's see, I just wrote down outliers, and that is center. Center. That's going to freak me out. All right, center the mean because it's symmetric. Spread. I will use the standard deviation, which, that was on my calculator. Notice standard deviation is given in 2 different forms. Calculator doesn't know if it was a population, which it would use sigma, or a sample. And so it gave us both. And I'm going to say, from the context of the problem, it's a sample, so I'm using S sub x. 2.3 movies. So the spread is 2.3 movies. Notice the units are exactly the same as the observation. By the way, this is standard deviation. Variance would be 2.3 squared. And I'm just squaring that over here. 2.3 squared. If I ask you for variance, that's the square of the standard deviation. And that's 5.29, and it's odd little units, squared movies. I've got shape. I looked at the center and the spread. Because it's symmetric, I used mean and standard deviation. For outliers, my rule of thumb is it's going to be significantly large if they are above X bar plus 2 copies of the standard deviation. So that's going to be 4 plus 2 times 2.3. And it'll be significantly small if it's below the mean minus 2 standard deviations. I'm just going to throw those in the calculator really quickly. So if I start with a mean of 4 and I add 2 times 2.3, anything above 8.6, and anything below negative 0.6. So 8.6, significantly high. No outliers because the largest value is 8. Significantly low is anything less negative 0.6. You can't have a negative 0.6 movie. So no outliers there. That takes care of my shape. Then I use center and spread based on the fact that it's symmetric instead of median and interquartile range. Symmetry dictates the mean and standard deviation. Using the mean and the standard deviation, I identified any possible outliers. Let me go back and check, see if I did all my work. That concludes part 1.